All right, very good. Thank you, Scott. Oftentimes the first call we get from a customer or potential customer is something to do with these top three problems. If you have a dust collector at your site, most likely, unless everything is working perfectly, you've dealt with one of these three problems. So go ahead and move to the next one there, Andy, and uh, and we'll go through them one by one. And I hope like as I mentioned earlier, maintenance people are usually our first point of contact that have to deal with this. So, maintenance guys on the line, hopefully we can be some help here. So the first one is no vacuum or no suction, right? We design these big systems with fans and baghouses sized based on the number of pickups or drops you have on your system. You started it up on day one, everything is sucking very well. There's dust being evacuated from your weld booth or your process, and everything is all good. What happens then a couple years later when that suction slowly decreases over time? And by the time we get a call, usually there's no suction over here. We've got issues over there. So there's a few things that we will go look at to diagnose that issue. So number one is the filters. It's a filter system, right? So just like Scott said, you have a filtration system with surface filtration where dust builds up on the filters. And as that dust builds up, the static pressure or the resistance to airflow across that whole system increases. So your fan might be pulling 10,000 CFM when you have 8 inches of static pressure in your system, but then now your filters are getting all clogged up with dust. So now you're at 12 inches of static pressure. So what happens if you go back to a fan curve, you'll see that the CFM essentially decreases in correlation with that. So first thing we always look at is the filters. And how do we do that? We go look at the differential pressure gauge on the baghouse. So every collector should have a DP gauge or a magnehelic gauge or a differential pressure gauge, all the same thing, right? It'll just tell you what that static or differential pressure is across your filter. So brand new set of filters, maybe at 1 or below 1 inch water is the unit most often used. As the filters get packed with dust, that will creep up to 2, 3, 4, 5 inches. And at some point, your filter cleaning system will kick on, blast it with compressed air or shake it, depending on your system. Whatever it is, it should knock the dust off. Static pressure goes down. And it should basically go back to operating the way you want. Over time, maybe you have reached that end of life failure where your filters are now blinded, your filter cleaning system isn't working like you want it to, and so the result is a static pressure that's higher than your design point and a minimized suction at your where you need it. So number one, we'll check the DP gauge. How are your filters doing? If necessary, we can do a visual inspection of the filters. They're totally packed with dust. There's your problem. New filters, problem solved, right? That's the best case, right? Easiest thing to figure out. Number two is leaks. So you have duct work connecting your baghouse, your fan to all of your pickup points. Sometimes that can be very extensive. You've got long duct runs. You have union fittings and elbows and hoods, which are all connected together. Over time, things can happen to that ductwork. You get cracks and joints come apart. You have abrasive dust that wears holes and elbows. You have interface points with flanges and other things that, for whatever reason, over time will develop cracks and gaps and leaks. And so, what does that do? That takes all of the fan or the airflow that your fan is pulling, and it's wasting it. And it's pulling it through those little cracks and leaks instead of through your nicely designed hood where you want it to be, right? So instead of 200 feet per minute through your hood, now you have lost, an eighth of your airflow over here. So you have less than ideal velocity, your pickup points, all kinds of problems, right? So that's number two, fairly common. Usually that's not the sole problem, unless you are talking about removing entire branches and leaving branches open to atmosphere, which we do sometimes see. So you want to minimize those leaks in your system. Go walk your ductwork, figure out where you may have air leaking, and fix it. Number two is the fan itself. So when we design a system, we design the ductwork first and figure out what the static pressure requirement, the velocity requirements, and the airflow requirements are for your system. We'll make the baghouse sized appropriately, and then we'll choose a fan appropriately as well. So if you look at how fans are selected, usually it's by an airflow and a static pressure. So that's great when everything is just as designed, right? But what happens over time? Something we see almost everywhere we go. That system changes over time. Someone has decided at some point to add a machine, or we're going to close this branch here. We're going to move it over there. All those little changes that seem fairly innocuous, they add up and they change the static pressure of your ductwork, and they will add a branch here. Now your airflow requirements have changed. That airflow is basically, the fan can only produce so much. So if you're adding branches, what are you doing? You're distributing it now between more pickups. And if you're changing the ductwork, your static pressure is changing. All that is changing the dynamics of your system. So your fan may not be up to the challenge now. It may also just be worn out. You may have a fan wheel that's been abraded with abrasive dust or something, and it's not pulling what it's supposed to do. So we'll look at the fan itself just from a basic maintenance and PM perspective and say, how does the fan wheel look? What's the fan RPM? We can stick a probe just upstream and figure out what the actual airflow and the vacuum pressure of that fan is, and make sure that it matches up to what it should be for your system. And then finally, some systems will have dampers, slide gates, and other manual methods of airflow control, which can greatly modify the balance of your system. So the fan itself might have a damper on the inlet or the outlet. You might have these located on trunk lines at various points in your system. And then a lot of the ductwork branches will have their own little dampers or slide gates, which people tend to open and close as needed. Your people, on the floor may shut off a branch or open a branch here when they need it. And all of that is changing the balance of your system, and it may be affecting your suction over here in another area without, realizing. So we'll go look at that and make sure everything that's should be open is open, and your dampers have some sort of methodology for how they're controlling your airflow. So vacuum problems come down to basically dust collection system basics, the filters, so the static pressure, leaks through the ductwork, your fan, what's the condition of your fan and how is it sized to perform, and then the dampers on the system. So those 4 things, if you're not getting suction, that should be your checklist to go look at. All right, next slide, Andy. Okay, the number 2 thing we hear is issues with cleaning. My baghouse is not cleaning. So most of the equipment that you'll have on your site are pulse jet baghouses. I know some people are working a big steel mill. You may have a reverse air type baghouse. Some people will have a shaker system. I won't get into the details of every system, but the most common thing is a pulse jet baghouse. So it's actually a very simple system. You have a timer. You have some solenoids, where basically just a little electrical valve that opens and closes. And you have a pulse valve, which takes compressed air and releases it through a blowpipe into your baghouse, 1 row at a time to clean your filter bags. So usually, if your cleaning system isn't functioning, one of those 3 or 4 components is the problem. So what I'll do is I'll go out and I'll stand there by the baghouse and I will listen. Now, if you have your timer set up on just a continuous mode, you know that at every 20 seconds it should fire. If it's not firing, well, then you can pretty safely say that either your timer board isn't working. Usually you can go look at it and see it'll have little visual indicators when each output fires. So check that. An electrical connection between your timer and your solenoid. So if you hear a click, or if you see the timer board fire, but you don't hear a click, you've got a solenoid that needs to be replaced. If you hear the solenoid click, but you don't hear a pulse of air, then most likely it's a pulse valve issue, or maybe it's your compressed air. Make sure it's turned on, obviously. Now, sometimes you have the whole system set up on clean on demand mode, which we recommend is the most efficient way. Basically, it means your system measures the differential pressure and it doesn't turn on until it reaches a set point, like 4 inches or whatever. So you might have to manipulate your DP tubes to get it to fire, but when you do that, it should activate the system. If it doesn't, again, it's one of those 3 issues. It's the timer board, it's your electrical connections or the solenoids, or it's the pulse valves themselves. Most oftentimes, if the system's firing, you hear it going, it's doing something, but your DP isn't really going down, or the bags are just not being cleaned the way you want. Most often, diaphragm, within the pulse valves, the diaphragms need to be changed. So when I hear it firing, you get to know the sound that it should have. It should have like a nice, firm, compressed air blast sound. If it sounds like a squeak or a whistle or a gasp, it's an indicator that your diaphragms are worn out, because they're just a little, rubber diaphragm in there. They flex and they wear out. Usually we recommend once a year, maybe clean those out, or replace those as part of your regular PM schedule. That way you don't have to go do this exercise of listening to them. It's just getting done. The other thing occasionally we'll see is open up the baghouse. We'll look inside and the blow pipes have been knocked out of place. They've got some kind of a bulkhead fitting that usually holds them in place, or some kind of fastener, various different types, and they do occasionally get knocked out of place. So that's something worth looking at too. And then finally, check the bags themselves. If everything is working, the pulse valves are firing, it sounds good, everything should be working, but your DP is still high, the bags are still dirty. Check those bags and see if you have moisture getting to them, because that can really impact the performance of the filters, first of all, and then your cleaning system as well. It's not going to be able to clean mud off the bags if you get significant condensation. So that's something we will occasionally see. So, okay, a couple items. You got your timer board, your pulse valves, your solenoids, the electrical connections, and your compressed air. So make a little checklist, go out there and check each one of those. One of those is your problem. If it's not, you have wet bags, then you should address that. But really, these systems are fairly simple once you understand the fundamentals, and that's where typically we'll find the problem. Next slide, please. All right. The final most common question is, why aren't my filters lasting? Or how long should they last? We always get the question, how often should I change the filters? How long do they last? As as Scott said, of course, it depends how you run them. If you're running 24/7, a highly demanding application, abrasive dust, all those things, they won't last as long. If they're sporadically used, light dust loading, they'll last a lot longer. But, general rule of thumb, I like to say, is like about a year. And it really depends on you, but people like to have a number to go by. So once a year is kind of a middle of the road estimate for how often you should change your filters. So what will cause them to fail early, or that end of life failure to not be as long as it should? Your cleaning system settings are important. So you want to set your cleaning system timer so that it's cleaning them enough to remove the dust cake and keep your differential pressure low, but it's not just cleaning them all the time just because essentially you're sending a shock wave of compressed air. It's flexing the bag, and over time you get like a fatigue failure, and the bags will wear out. We always recommend using clean on demand, again, so you're not hitting them with compressed air until they really need it, right? You wait till your differential pressure gets to a set point, it runs a cycle, and then once you get below the low point, then it will turn off. That will help extend your bag's life. Washing of bags. We run into this from time to time. There are people out there who offer the service of laundering filter bags. Sounds like a good deal to save money on bags. Problem is, specifically with felted filter media, which is most commonly used for filter bags, introducing water to the filter fabric will basically degrade it and break it down. Just like if you've ever had a felt hat, or those old-fashioned kind of felt hats, if you throw it in the laundry, it will not do well. It'll basically fall apart. Same thing happens with felted filter fabrics, like felted polyester and things like that. If you're in a pinch, you got to do what you got to do, right? Sometimes if you don't have an extra set of filters, which we of course recommend you do, and your system's down, some people will go and launder them and just to get their system up and running. I get it, but you should not expect those filters to last too long. That should be a stopgap and not something you do as a regular process. And then finally, filter media is extremely important. you have to have the right filter media for your bags. If you have a high temp process of any kind, you really need to talk to someone like our sales team here who knows how to assign the filter media that matches your application. So different fabrics out there have different temperature ratings, different resistiveness to abrasion and chemicals. There are various options for coatings for really fine filtration or higher efficiency filters. All those are options, and you should not ever just pick a bag that fits without knowing what it is, because you over temp it and it will fail, or if you have moisture in your system, something like that. So the right filter media is critical. The right fit, I'll just throw this out there, because a lot of times we'll see leaks that are kind of hard to trace. Bag looks in good condition, but it's the fit of the bag on the cage and in the tube sheet. It's not right. You can have leaks through there. So whenever we're quoting filters, it's very important that we get those dimensions right. There's some articles and blogs that Andy has put up on the website, and you can always ask one of our people for help so that we get the right dimension spec for your filter.